All right. So let's look at, we're going to talk about pseudocode and flowchart, CSC200 here. So, but we want to look at the real world problem first. So we need to solve the problem from the real world, right? We try to write an application. An application is going to help solving the problems. So how are we going to make the real world problem into a formula or something that we can compute, right? Or calculate. So we said we can use an algorithm to help solving this problem. So what is an algorithm? Algorithm is pretty much just like a set of instructions, right? Let's say example. Let's make the real world problem very simple. I want to find the sum of two numbers. We know that we can ask user to provide input, right, for two numbers at the keyboard. How are we going to develop the algorithms to write this application? So we said we can use the keyword read, pretty much stand for input, right? First number. Now when you do this for the program, you have to make sure that program has to define, like, break down all the instructions. So when you read, if you look at yourself, if I give you the number 5, so input could be in your ears is your input, right? What did you do next? You actually store it there on your brain, right? Now you have 5 in your memory. So the same thing. If you said, okay, input for the computer is going to be keyboard, we can use scanner, right, to read input. After we read input, we have to store into the memory. That's why we declare variables to store it, right? So this is step. So we read and we store in the computer. So we get the first number. So we did the same thing for the second number. We read and we store it, correct? Now after this two, we want to find the sum. I give you 6. What do you do already? You have 5, you have 6. You actually store them in your brain, which is in your memory. So the same thing happened in the computer, right? You store into variables num1, 5, num2, 6. Now you happen to have added 5 and 6, and then you start to store it in your main memory, also in your brain. And you say the answer is going to store, but you not display it out by saying out yet what the sum is, because I didn't ask you yet, right? So the same thing, the machine has to do the same thing. We're going to store the sum into a variable's named sum, right? And by adding it with 5 plus 6, right, with the pretty much just mathematical operations. Until last step, you have to do system.out if you want to display onto the screen the sum is. So that's pretty much pseudocode, just like you read, right? You read first number and store first number. You read second number and you store second number. And you add first to the second and store into the sum, and then you display the sum. So this pretty much just an algorithms, right? Algorithms is pretty much just lay out a step by step of each instructions that you need. That makes sense? So just like the same way that we do, but we do it very fast because we just used to the process, right? So this is just what does compute mean? Compute pretty much just to do calculate, okay? Like we want to manipulate the data, like we add, we subtract, those are compute. So we use this as a keyword for pseudocode. So when you design a program, at this point, you pretty much just write a code right away. You jump into implementation process, right? Where it asks you to write a program, like to find the height, you just open your editors, VI, Notepad, or IntelliJ, and then you start to write public class, the class name, public static void main. You start to write input. So this is called the coding phase or implementation phase. But in reality, when the application is more complicated, you can't really just jump in and implement right away. So we need to break into two phases. One is to design or create your algorithm first to solve the problem. And the second one is just implementing it by translating the algorithms into the programming language. Now, it doesn't have to be Java. It can be any languages. So pretty much the algorithm phase or the problem solving phase here, that's why we have a standard. It can be using pseudocode, right, or flowchart. Now we gotta look at what is pseudocode. It's just a way to describe an algorithm, help programmers to plan an algorithms, like the first phase, right? It's not the actual computer programming language, but we use some syntax from it. The styles are vary. You can have your own, but make sure that you're going to use some keyword that very common, like prompt, read, right? So let's say, for example, of this pseudocode, we look at the problem. The real world problem is, I want you to create a build, like when you go to the grocery store or when you purchase something, right? So you get a receipt, right, of the bills. So I want you to write that application. So before we write an application, we say we have to go to the solving problem first, right? So how do we do this? The solving problem first, how do we do this? So we said first you have to prompt. So I give you some clue here, right? Prompt for number of items being purchased, right? Like I want to buy a Coke, how many Coke, right? So that's the number of items. Okay, I want to buy 2 Cokes, right? Read number of items being purchased. Prompt, of course, you have to prompt first before, like we read, just like enter the number of Cokes, right? And then I said 2, then program read 2 in. That makes sense? So what should be the next step? I need to know the price of the item, right? Per item. So you have to prompt enter the price of the Coke. So you read the price of the Coke in. Now you want to calculate. You see that we have the pseudocode keywords are in caps, right? So you're going to calculate for subtotal. How do you do that? Pretty much just the price per item times the number of items. Then you're going to store into subtotal. After subtotal get, you have to do calculate for tax, right? So you need to get the tax rate, right? If it's 10%, just multiply by 10%, right? Subtotal, then you get the tax. Then you have to calculate for the total. And then you display the total. So this is all the pseudocode for this application. Any questions? All right, so now let's look at there are some common pseudocode keywords that you should use, like to read input in, we can use read, get, or input. To display, we can say print, display, show, prompt. To compute, we can do compute, calculate, or determine. To initialize, we can do set or init. To do, like if you want to add by 1, we can call increment or bump. If you get to decision, like last time we started to talk about if else, you can do test if then else while do. So we're going to talk about the loop, right? So when you write a pseudocode, you have to be certain that the tag is completely specified. Like what data is known before program runs. What data must be input by the user? What computations will be performed on the data? What data will be output to the users? So very simple, right? Input, calculate, and output. Input, calculate, and output. Those are the questions. Like what are you known? If you already know, then you are not required to prompt the user to enter in. Like for example, go back to the calculated bills again. If I know the price of the Coke, do I need to ask the user how much per item? No, right? You can eliminating that part if you set the price in the program already. But of course, we still have to ask for how many items, number of items, right? Because we can't know that that's can be input, right? That's a known, and this is going to be input. Price known, number of items input, and then if you already know the tax rates, you don't need to ask for tax rate. You just do computation for subtotal and then tax, and then display total. Very simple, right? Now I want you to do this one for me. Calculate your 2 children's allowances based upon 75 cents per year old. How will you do that? Okay, how old they are. So you prompt the user for how old they are and what else. We want to break down as much as we could step by step. So you want to prompt the user first, or remember, go back. These are the questions that you have to ask. What you already know. What do you want for input? So you actually want to start with what you already know first, and then you only prompt the user for unknown information, correct? So what you already know. Okay, 2 kids. 75 cents per kids. Per year, I mean, right? Then we just set it could be a constant that's say the rate is 75 cents per year. First, this is already known, right? And what should be input? The ages of the children, right? What's next? You want to calculate now by multiplying, right? So we just multiply age to the rate, and then we get allowance, and we record it into a new variable named allowance, right? What's next? So you're going to display, right? So known, input, calculate, and display, right? Output allowances for each child. Very simple like that, right? That's how you break down the problems. That makes sense? Now we have the problems, say what is already known. What do I need to know? Inputs, right? Start to calculate and display output. That's it. Simple. 4 things. All the applications is like that. Think about what is the application that you use almost every day on your phone. Huh? Clock. Okay, if I want you to write a clock application, normally you don't need to ask user for anything for that one, right? The only thing that you ask user is what? To press the button and show me the time, right? So that even simpler, like what you already know.
The prompt would be how old the kids are, and then that's before the input.
Here, right? We ask for ages of student. Just prompt and read and prompt and read, right? So for the clock, you already know what? The system itself should know the time. How does the system know the time? Operating system. Operating system should already know the time. You don't have to worry about further than that because someone built the OS for you already. You don't have to, unless you want to find out how they build the OS, then that's another question. But now we want to write an application to display the time. We don't have to worry about how to build the OS. Otherwise, your question is infinite. You keep asking and researching, which you off the track. So now, how do we read the time from the OS? This is not algorithms anymore. This is how to write a program. What is Java syntax? That should cut out in the design phase, right? There are 2 phases. First phase is what? Algorithms, right? The second phase is implementation. Now, algorithm said we already know the time from the OS. That's it. Done. We know the time, so we set the time, getting the time from the OS system. And then, do we need to calculate? We don't even need to calculate unless your machine happen to be, you read the time from the server in California and you are on Eastern, then you probably pretty much have to do adjust it right according to the standard time zone by +3. That's calculation part. And then you just display. How to display? You already system it out. If you want to display on the console, if you want to be more fancy, you already know how to display on the JavaFX dialog, right? That makes sense? And that's it. That's very simple. So that's algorithms for that. Now to implement is another story. Then you have to learn how to implement, which different languages, computer languages, can have different syntax how to read the time. Like in Java, just do date. You use date class, then you can get the time from date class. Date, new date, you get the time. You see that? So you should separate your concerns into 2 phases. You should not combine them together. That's why designing algorithm is important. You don't want to bombard the issue of the algorithms with the issue of how to implement, right? So this is a pseudocode for that. Prompt for age of child 1. Read age of child 1. This is pretty much heavier. You ask that, right? Because before this is just the algorithms. And now we just do pseudocode. Right? We use a keyword prompt. And read, right? And prompt again and read since we know the two kids, right? And then we calculate for each kid and we display each of them. That's it. You think you can handle this? It just need to lay out your idea into pseudocode. And if you don't know how to lay out, we start with the question, what we already known, what is the input, what is the calculate, then you start to develop your pseudocode from there. Make sense? What need to be displayed. All right, so let's say we're gonna look at our assignments that you need to write pseudocode. So go to the class exercise. This is going to be 3.3. So you can write a Java program to authenticate a user login for username and password. Requirement, you have to write the pseudocode. All right. It says if username and password are correct, then display welcome username message. Else display wrong username or password message. This should be very simple authentication. But before we write an application, we want to work on the pseudocode. So I need your help to work on this together then. We just learned how to write the pseudocode, and now we know that the real world application that we want to solve the problem is authentication. How do we write pseudocode? All right, so it's just writing, so we can just use Word documents, right, as an editor tool or even Notepad. All right, so let's start with pseudocode here. So what's the first thing? Remember, if you don't know where to start, we have to ask ourselves what is already known, right? Do we know anything? What do you need in order to authenticate a user? Username. Do we know username? No. You need a password. Does the system know the password? All right, that's a good question, right? So let's revert back the question. Do we know username? Does the system know username? That should be the question, right? Yes, system known the correct username and system known the correct password. Is that right? So what are the known item again? The correct username and the correct password, right? How does the system know? When the user sign up, they create username and password, and the system store that into the memory. Okay, now application doesn't ask you to create a sign up, then be not worried about that. But application asks you to authenticate. So that means we need to find out how to get the correct username and correct password, right? In the real world, it's going to record in the database, right? Whenever user authenticate, it's going to read that And think about where would it store when you read from the database? In the variables, right? So in this case, we're going to have to create a variables, two variables for the correct username and correct password, right? That we already set the username. Now in this case, we can just say use CSC200 as a username, the correct one. So we have to pretty much keep the value for now, right? And the password is password then. All right, so now the system known the correct username, which is CSC200, and the correct password is password. Any question on this part? Good question. What's the difference between variables and constant?
And so like later it'd be user entry equals the constant, yes or no?
So the constant, what is constant? Constant so first, it is a value that stay the same, like pi 22 divided by 7, which is 3.1414, right? Always, can you change the pi value? Because pi is a constant, right? Variables is the vary, right? The value that can be vary, so that's why we call variable. Variable should not be pi. Like username, password should be variables. So what else do we need? We already know this, so we need the input then. Input is the things that we don't know. What are the things that we don't know and we need from the user? When you hit login, we need that username, right? Because we don't know what the user is going to type in, correct? And how about the password? We don't know too. User has to provide, right? So we're going to say input username. Pretty much the username that user input, right? Input password. So if we want to break down this one to the algorithms, we pretty much we will talk about that, right? We just say prompt, right? So we will say prompt for username and prompt for password. So this is we already known. So prompt for username, that's for input, right? And then you have to read username, correct? And then you have to do prompt for the, this is pretty much just input, right? Prompt for that input username and read the password. Now we start to write the algorithms here. So we start to write the pseudocode, right? So pseudocode for the known value, pretty much we could create username, right? The correct username here and the correct password here. So in Java, we don't want to use spaces, right? That's a syntax. So I just create variables with the camel case right there. Now, what's next? Do we need anything from the user? Known, already do. Input already done. So the next step is what? What's another question? Calculate, right? Calculate pretty much just determine, right? Or compute, right? That's what I say here, right? Or compute, right? What do you try to compute here? Right, if the correct username matches the input username, right? Okay. How do we do that? We can worry about just pseudocode. So let's look at how you write pseudocode for if, right? So that's why we talk about flow of control statements when you have to decide whether or not to execute a particular statement. Also called a selection statement or decision statements, right? So example, if hours work over 40, then display overtime pay, else display regular pay. That's how you write pseudocode. Let's look at another example. So we said you want to calculate the child's allowances again based upon 75 cents per year old if she's under 10 and $1 per year if 10 or over. So we modify the question a little bit. Then we set up two rates, young rate and older rates, right? And we had a breaking point which is 10. So these are the known values, right? So input the age of child calculations, that's the formula, and output allowances. So let's look at the pseudocode. Prompt for age, read for age. If now when you read the age, you have to do before you calculate. Right? The difference before we just calculate right away. Now we have to make decision. If age less than 10, then you go use the young rate. Else use the older rate, right? And then we start to display. All right, come back to our authentication. How do you do that? So how would this algorithms look like? We add the calculations part, right? How do you compare? Username, pretty much do a correct right username equals, or in pseudocode we don't use that, equals to, equal is Java code, right? Equals to what? Username, the input username, right? That's how you calculate, right? Correct. So same as what? The password. So now how you write the program, like write the pseudocode, I mean. Like we gonna start to say, once we get known value and input value, then we can do if like this, right? If age less than 10, right? So this one is gonna be if equals to, right? Like from the compute here, right?
We just say like if usernames match, or do we have to say if correct username equals the input?
If username equals to, right? You could say if correct username or username doesn't matter. The order doesn't matter here, right? It can be commutative, right? Like if correct username equals to username. What else? And correct password equals to password, right? What do you do? Then, right? We use the keyword then, right? Then what do you do? According to the question, say welcome username. Pretty much just welcome followed by the username, right? So we gonna say display. That's the pseudocode keyword, right? Welcome username, right? Else, what do you want to display? It's say here, right? Wrong username password. So voila, we done with. We are done, huh? This is pseudocode is done. Is it something that you can handle? Like this is compute part and display part, right? I mean, for the list that I'm creating here is not required you to create, but it's actually help you to lay out before you try to write pseudocode. Then you already have all the questions known, input, compute, and display. And then you start to write pseudocode. And pseudocode for authentication should be just like that. Any questions? All right, so this is pseudocode. Now, look at flowchart. So let's talk about flowchart. I'm going to use this document to talk about flowchart. So what's flowchart? A chart that has the directions, like chart symbols are parallelograms, rectangle, diamonds. So when it's parallelogram, we represent input or output, right? Like a symbols, right? And then we have the directions. So pretty much you represent your algorithms using a graphic instead of text, right? That we do with pseudocode, right? So, but you need to know is just like in pseudocode, you have to know the keywords like read, right? But in flowchart, we use the parallelogram symbol. Like calculate. In flowchart, we just use the rectangle, right? Or compute, right? Process, right? We use rectangle. Right? If else, we just use the diamond when you talk about decision. And then we have the arrows to show the direction, like the flow direction. And then if you are talking about the methods in Java, which is a function, you could just use this symbol to call the function, which is a rectangle with the two other lines inside the rectangle. And we use an oval to represent starting the program and ending the program. All right, now let's see. Now we start to see that when you talk about a program like before on Pseudocode, we have a sequence going on. You do step 1 first and then step 2. Like, for example, we read input, prompt, and read, prompt, and read, and calculate, and display. Those are the sequence that has to be. You cannot display before you prompt, right? Or calculate. You have to do prompt, calculate, input, and display. Otherwise, the order program not going to work when the order is different. So this is a sequence flow. So in Pseudocode, pretty much just write line by line after each other as a sequence. Like A comes before B. You have to do A first before you do B. Now when we talk about making decision, this is an if statement now. So you could do if, like in the case of authentication, so you will say if the username equals the correct username, right, inside the diamond here, then we will say welcome. Else we will display wrong username. Right, so if it's true, it's going to do the A. If it's false, it's going to do the B in the else statement. And after it's done, it's just go back and connect together to do the next sequence. Okay. Now, what we have learned so far, we have learned a sequence, and this is called branching, when they have to start to branch into left and right. So this is called branching statement. Like we have to do selection statement, true or false, something like that. So that's what we have learned so far. Now, let's talk about what about this one, right? So this is a loop. That means you pretty much just based on the decision, right? We still use the diamond for decision to keep repeating doing the A over and over again until the decision is not right. So when it's still true, you keep doing A, action A. Like for example, we have class every Monday and Wednesday at 2 o'clock. So A pretty much we have class, right? While it's Monday and Wednesday at 2 o'clock, we have class. While Monday and Wednesday at 2 o'clock, we have class. We keep doing that. Now, if you notice this could go forever if you don't have the stopping point, right? Stopping point is until the last day of class, which is in December, right? December 10th, something like that, right? So we keep doing this and we keep checking the date, right? While Monday and Wednesday at 2, and right, and now we add another condition to stop it, right? And the date is not December 10th. You're going to come to class until December 10th. Then we stop going to do A, we exit and do something else. Have fun, right? So that's pretty much just an example of using the loop to solve the real world problem. Let me show you another example in flow of control here for the pseudocode. Loop statement, right? So loop statement repeatedly execute the same statement for a certain number of times or until a test condition is satisfied. Like how to write a pseudocode, we use the key while, that's a key, right? Keyword for pseudocode. Population under the limit, we're going to compute the number of population plus births minus deaths. So we keep getting the number of population. Alright, so this is another example. Calculate the total allowance paid to each of 3 children at $1 per year old. So what's the known values again? $1 per year, and the known values also 3 kids, right? So before we just did 2 kids, so we could do known value as 2 kids too, but we simply just prompt like kid 1, right? And read kid 1 age, right? Prompt kid 2 age and read kid 2 age, right? But now, if we were talking about 3 kids, we said we could do the same. Prompt kid 1 age, read kid 1 age, prompt kid 2 age, read kid 2 age, prompt kid 3 age, read kid 3 age. But it starts to be redundant, right? Like if I have to plan to say 100 kids, 60 kids, you don't want to keep doing that over and over again. That's why we start to say this is repetition, right? When you see something that repeat over and over, you could use a loop, right? So let's look at example how to use the loop. So the inputs that we need are age of children, the calculation we already known, allowance, age, time rates, and we output the total allowance paid. Let's look at pseudocode now. So first, this application want to get the total allowance paid, right, to all the kids. So we set the variables named kidPace to 0. Remember, this is how you initialize the variables too. Use the keyword set. And then you set the total to 0 too. Now we start to use the loop here with the keyword while kids paid under 3. We just check, right, how many kids have been paid. So under 3, do prompt for age and read age, and then calculate allowance equals to age times rate, and then add allowances to total, right? That's why we declare totals to initialize to 0 to keep tracking, right, the sum, right, of all the allowances. Now we start to see that we say kid pays to 0. That means we want to keep count of how many kids have been paid, right? If we don't initialize this, then this program will keep looping forever. Just like I said, you should have the cutting point, stopping point for the loop, right? So this is it. 1, we start from first time, we didn't pay any kids, we count to 0. Now we start to pay the first kid, so we have to do increment kids paid, right? So kid paid changed to 1. Now we're not done yet, so we're not going to display yet because the loop's still true. Remember, when it's true, it's going to go back and do the prompt for age for the second kid and read the age, right? Let's go back, it checks kid paid is 1, still under 3, so it's still do. What does it do? Prompt for the age for kids number 2, right? And read the age of kid number 2 and calculate the allowance for the kid number 2 and add allowance to the total, and then start to increment the kids paid. So we just finished calculate 2 kids. So now kid paid increment to 2, right? So we go back and check the condition again, right? We're still in while loop, that's why we indented here, right? So 2 is still under 3, so we do the same prompt for age. Read age, calculate the allowances for kid number 3 and add allowances to the total. And increment kids paid 2. Now from 2 becomes 3, right? And all 3 kids has been calculated. So let's go back and check the condition again. So while kid pays under 3, is it under 3 or not? No, 3 is not under 3. So it's no longer do the blue bullets, right? Because it's only do when it is, right, the while condition is true. 3, that means no longer do it. It's going to go out of the loop and display the total. So that's how you calculate this total allowances for 3 kids. That makes sense? All right, so we just seen how you use Pseudocode for the loop. Now let's look at the flowchart. So we've been mentioned about this already. So for the flowchart, let's look at this sheet again for the loop, right? We talked about that. So you just keep looping and execute statement A and loop. Like in this case, while child under 3 is going to calculate the allowance, which is tax A, and keep increment, right, the number of kids paid, and loop until while it's not under 3, which is 3 kids have been calculated, then it's just go out of the loop and do the display or whatever statement that come after this. All right. So any questions on loop? Now if we don't have any questions, so we want to move on to look at an example. And before we go there, this is just another type of flowchart that just like the decision branching, like true you do this, false you do this. But this one just you have more than 2 options to select. This is like 4 options, right? If case 1 you do A, case 2 you do B, case 3 you do C, case 4 you do D. All right, so now let's look at flowchart example. All right, so now you want to put the flowchart all together. Before we come back to this example, I want you to look back into the slide first to do step by step here. So like we said, we use the rectangle for calculations. So if I want to find the total of the bills, then pretty much just total equal to cost plus tax. You put that inside the rectangle. So if you want to do, remember, we have to read, we have to write or prompt, then we're going to have to put in the parallelogram like that. Read the number, write the number when you display, right? And whenever you do decision like true, you're going to do this, false, you're going to do this. Like this is pretty much just the interest rate based on the amount that you have, something like that. So if you have more than 50,000, you get the rate paying at 30.31%. If you have less than 50,000, just pay at 0.28%. So every algorithm starts somewhere and terminates somewhere. So that's why in the flowchart, we should have the start in an oval or, yeah, circle like that, and then we should have stop. Okay, after the flow, like input, calculate, output or display, and then stop. So let's look at, this is a pseudocode for calculating the allowance for 2 kids, right? And display that. So in flowchart, pretty much just mapping into pseudocodes just like that. You use the parallelogram for prompt and input or read, and prompt for and read for each child age 1 and 2. And then you use rectangle to calculate allowance for age 1 child and age 2 child. And then you display them, use parallelogram again for each allowances. And then stop, start and stop. So that's example of flowchart. And this is not example. When we were talking about young age and old age, right? You start, you prompt the age, you input the age. So now we check if the age is a young. If it's young, then you go to true, calculate for the young rate. Young mean we cut off at 10, less than 10 years old, and then we print the age. If it's old age, then it's to false, it's just multiplied by the older age or rate. And then we print the allowance. So this was just the first one showing the sequential, right, flow chart. The second one showing the branching flow chart. And now this one showing you the loops, right, flow chart. And this is just based on the number of kids, right, 3 kids. So we just do while it's still less than 3. If it's true, you just prompt age, read age, calculate allowance for age, and add that to the total and increment the number of kids paid. So the key is increment in rectangle. Here is the key to terminate the loops. Because most of the people who never write program with loop before, they will have problem with changing the values to increase to make sure it's exit the loop here. You have to initialize to 0, make the condition less than 3, which is 0 still less than, so keep doing it. And then you keep increment that to 1, 2, and 3. So 3 times, then it's false, then exit and display total and stop. So that's the flowchart for loop. So a flowchart pretty much just details exact how you program, like how your program will do each task. Yeah. So the next one we want to look at is structure chart. Okay. So structure chart shows only what tasks your program will do, not how it will complete them. It's just like a hierarchical diagrams. So it's going to show relationship between all the tasks in the program. It's going to indicate which data is shared by the tasks. A large program design is first broken into tasks. So like if your program is big and more complicated, we want to break into small tasks. And tasks are repeatedly divided into even smaller subtasks. Rectangles are used to represent tasks, subtasks within the program. Lines are used to hierarchically connect tasks and subtasks. Subtasks are diagrammed below the task to show that they are part of the task, like that. Alright, so we use the arrows to show the process of data between the tasks. like up and down, like you get the data 1 from task subtask 1 and you pass to task, and after task is passed, then you pass data 1 to subtask 2 via task. Data also be passed both into a task, right? We use downward arrow and pass back use, like this is downward, this is upward, right? So given a generic program that reads some data from the user, runs some calculations using the data, and display result to the user, the structure chart could look like this. So we said this program reads some data, so we get input from the users. This is the main program, right? We start to do like separate tags. This tag just to get inputs, and this tag pass the data and process data and get a result, and the result pass to the display task. So that's just a simple structure chart. So now we're going to use this structure sequential program design example to calculate 2 children allowances based upon 75 cents per year old. So the chart should look like this. The first task is to get ages, age 1 and 2. You pass ages 1 and 2 for calculate the allowances, and that's return allowances 1 and 2, and then you do pass to display allowances task, which will just print out to users. Alright, so let's look at another one. So this is pretty much if you want to calculate the, let's see, we look at, this is calculate 2 children's, right? Allowances based upon 75 cents per year old. So you pretty much just going to get 2 edges, pass 2 edges, get 2 allowance, and return 2 allowances. And this one is just for 1 child, right? Pass 1 child, get 1 child, pass 1 child in, calculate and return allowances, display allowances. So they're gonna use the same structure. Each of these modules in the chart would be called by main twice. So meaning that we using the modules is going to, like one module is calculate 1, right? If you have 2 kids, you just use the same modules, just passing 2 values instead of 1. Then you get 2 allowances out. So this module is pretty much just something that we call like a method or a function or procedures. Maybe we decide to program this way. So let's look at, we're gonna look at the looping program, right? So calculate the total allowance paid to each of 3 children at $1 per year old. Okay, so the main program start. So first we have to get the age, right? So we get the age, and then we call the modules to calculate the allowances, and pass the age in, get the allowance out. And then we have another modules to do the calculate allowances total. So it's gonna keep adding, and then we display the total. So the get age and calculate allowance modules would be called every time the program loops, right? Like this time it's going to keep calling. So when you decide a modules, it's going to be called All right, so it's in summary. You put the name of the program in rectangle, root of an upside down tree. You determine the main subtask that must be performed by the program to solve the problem. Put main subtask in rectangles below the root and draw a connection line from the root to each subtask. So this is showing you how to create a module or the structure. And examine each subtask individually and break them down into even smaller tasks. Put subtasks in rectangle below the tasks that they are part of and draw a connecting line from task to subtask. Repeat until the bottom tasks of the tree are very simple tasks to complete. Alright, so this is just showing how pseudocode and flowchart and structure chart is created. What our focus here now is we just want to focus on getting the flowchart and pseudocode. So I want you to look at another example of the flowchart. So this is, if I want to find an average of 10 numbers, how would we draw the flowchart, right? So first we say we start the program, we get pretty much just prompt for number 1, right? And then read number 1. If you're repeating that 10 times, this loop is going to be changed. It has to connect, this line has to connect there. But if we want to read 10 numbers at a time, then we can just prompt once, right? And then the user could separate by space, right? And when we use scanner, we can just do delimited, right? To read 10 of them. And then we add the numbers, right? And then this is just check if you have 10 numbers yet. If not, then we keep adding. After you get all spaces, keep adding. I mean, if you read it once, and then you keep adding each number by using next, right? Till 10 numbers. Then we check, okay, we get 10 numbers already. There's divide by 10. Now, in order to get to 10 number already, we have to do incremental count, right? Or read to the end, right? So something here has to be changed a little bit, right? And then you divide by 10 and print the average and end. So that's pretty much a flowchart. Now, come back to your requirements, right? So I show you pseudocode already. So how would you do the flowchart for the authentication? So pseudocode you can just write down on Notepad or Word, right? So flowchart, you could use like any application that can draw the chart. I mean, Word document has the diagram too, but this is one of example that you can use too. Like you can just sign up for a Lucy chart for the free account and you can use the tools from this one. Okay. All right, so after you start sign up, you can get a free trial. So let me just use the blank flowchart. Now you get to the tools that you can just drag and drop, like these are the flowchart. So first you want to do the oval, like we said, right? We can call start, right? So when you start, you can draw the arrows to, this is a flow direction, right? All right, so what do you want next? This is for authentication. We said we want to read input, right? Or we want to initialize first what is known, right? Right. So we want to do this, use this for that initialization, the call preparation with the known values. So we can say correct username, right? Equals to CSC200. And then you also want to set another one. You could do more than one, okay, in the same like shape. Let me just see if I can do like new line entered. Correct password equals to password. Okay. So now we get a known values. What's next? You want to get input from user, right? So how do you get the input from user? Input was a symbol, parallelogram, right? So what do we do? Prompt username, right? And then the same, you're going to read the username, correct? And then the same with prompt password and use read password. When you use this, it's pretty much just make it easy for you to draw the chart, right? Like these tools. Read, because these two can do both input and output, so prompt and read, so we use parallelogram for both. Read username, and then technically it's the same thing, so but just change it to the password. So I'm going to just copy it and put it right there, right? Now we do with the password. So after that, what's next? You start to make decision now, right? That's a compute part, right? So what symbol do we use for that? The diamond, correct? Decision, we use diamond. All right. Now just say correct username. Just check, right? If it equals to why don't you enlarging this, then we can fill in all the text. If the correct username equals to what? Yeah, equals to the username that I define as username right here, right? Read password, right? And I define read username right there, right? So, and then we have to do and too, right? Password, right? Correct password equals to password. So if I use lowercase, I need to just make sure I do the same. right? I read and put into variables like username and variables name password as local cases. All right, so in this case, if it's true, what do we do? Right. So you go draw the line when it's true, then you display, right? When it's false, you just display like error message, right? To just welcome message. Yes, right? And display, we just use this, right? We just say welcome, right? Username. And when it's false, you just draw is another one, no. See that? And then no, we can say wrong username or password, right? And then we pretty much done. Then we have to end with what? An oval and call it stop, right? So this is just let me use an oval instead because I've been choosing oval. I'm going to pick a circle. Let's draw the line again. And then an oval and just say finish. And then you connect this line back to this one. So we're done. So that's a flowchart for that. All right. And then you could, just export this as PDF. Okay. Save as and then attach to the submission. Right. Authentication. And that should be pretty much flowchart requirement and pseudocode requirement. The rest you should know how to write a program. Just start to translate them and write into the code now. How to read, how to compute with if else, and how to display with system.out. Right? You need to do the Java doc, generate it with, and then use git bash to submit, which is you already learn how to use git bash command. So from now on, we just keep doing vi git bash command. Okay. All right. I think that's it for today.